Hello and welcome to the SAFI Learning Center. This short tutorial will demonstrate lifting a mast. Let's say we want to lift a structure from the top without having supports at the bottom. Let's do some work in that direction. We will remove the support at the bottom and we will add something at the top that will support that structure. Maybe first we can just create a few extra members like a frame above the structure to support it. Let's extrude the selection first. Also, we will do a copy of that one here. So, I'm just creating a frame using the same members as the existing structure. For sure, it is a simplification for this example. I will copy that member from here to here. Then, we will assign some sections to the new extruded members. Let's create a new standard section from the bars library. Let's say it is a 1-inch circular bar. And then, let's say that the new frame here will be supported by one single point with cables at the top of that. Let's add here the new members. Make sure they are cut in independent members so they are acting as separate members. Then, I will move this point, let's say, 4 feet above the existing structure. Let's apply to those members the same circular bars as the members done before. Let's assign a support there. Let's suppose it is a fixed support. Let's try to analyze that as it is now without refining the model. By experience, you will see that this will not work very well. It is a step to show that there are other things to pay attention to. Let's run it like that. There is a warning. Verify structure stability. Joint displacements are high. Do you want to continue? I can click yes and continue, and you can see that there are very large displacements. If I display the structure displacements, it is not something you would like to see. It means there is something missing in the model. In addition, we also forgot something. These cables need to have bending releases. If they do not have hinges, they will develop bending moments at their ends, and this is not corresponding to the behavior of cables. In addition, we will add hinges at the end of these members. Let's run it again. It should be even worse now. I'll get another warning saying displacements are very high and the structure is almost completely unstable. An easy way to fix that would be to add minimum spring stiffness at different positions. These springs are artificial but will stabilize the structure to see its behavior. Let's add a few springs along the X direction on the left side. For example, specify a very small rigidity of 100 pounds per inch. Let's do something similar for the Z direction for other points here. And reanalyze the structure. It seems no warnings have been displayed. Let's take a look at the displacements. It is much better, although it is still not perfect. I am looking at the structure from a front view. Everything seems to be correct. From a right view, I still see something that doesn't seem to be correct. Let's take a look at the reactions. The internal deformations are already displayed. Let's take a look at the horizontal reactions, mainly along the Z because it is in the direction that we see displacement and also along X. You see here there are small reactions. Let's just display reactions around Z. We get here 25 pounds, which is not so high, but it also means that if the spring would not be here, there would be some rotation of the structure. Why do we get this rigid body motion of the structure? It is because the supporting point is not exactly above the CG of the structure. We should move that point here so it is located exactly above the CG of the structure. To identify that, let's try to calculate the load CG. It seems that the CG is correct along the X direction, but not correct around the Z direction. We will verify the CG in that direction. If I use the Calculate Load CG command, I can see the CG per basic load or per load combination. I am now looking at the reactions for the combination number 1, including everything in load combination number 1. This is the CG along X and Z for this load combination. So, I will copy this Z coordinate and I will fix the joint coordinate Z equal to that value. Let's reanalyze the structure using that new location. Now, we seem to have very good results. You can see that there is no more reactions on the springs. So, there is no more displacements and no more horizontal reactions. The structure is now supported from the top. Let's have a look at the axial force. We will see the behavior of the structure. Let's activate the axial force on the members. We will adjust the scale to something else. We'll put 1 kips for axial forces. Now we can see that the axial force is at maximum tension at the top, and in the cable it reduces at almost 0 at the bottom. I hope you enjoyed this video. For more videos and information, please visit our website at www.safi.com.